Greetings! Welcome to the Perennial Gadgeteer. Today we are going to focus on the linear tracking turntable. Most consumer-grade linear tracking turntables were made in the 1980s, just as the CD was starting to make its way to the market. As the saying goes, the rest is history, as CDs mostly replaced vinyl. But today, vinyl LPs are generating new enthusiasm among listeners who appreciate the depth and complexity of the sound. The record player, as a result, is making a bit of a comeback for home listening.
Most phonograph record players use pivoting tone arms like this, which is not really ideal because it means the stylus will move in an arc rather than a straight line, and since records are cut linearly on the recording lathe, this means there will always be some tracing error as the stylus moves through the record, resulting in a certain amount of distortion in the sound. There are always at best only 2 points on the arc where the stylus is perfectly tangential to the groove. In addition, there is another problem. Due to the offset between the axis of the cartridge and the tone arm pivot, as the disc rotates, the frictional force exerted by the grooves on the stylus tends to draw the tone arm toward the center of the record, which can cause distortion in the balance of the sound and uneven wear on the grooves and stylus. To counteract this, an appropriate anti-skating force has to be applied at the tone arm. The anti-skate mechanisms of most turntables are a compromise at best, though, because the peripheral velocity of the groove against the stylus varies as the groove moves from outer to inner sections of the record. The best you can hope for is that it will minimize asymmetric wear of the grooves and styli over most of the record, but it can never eliminate it entirely. A linear tracking turntable, in theory, should be able to eliminate both of these issues and greatly simplify things from a geometrical standpoint. Since it always tracks tangentially to the groove, there would be virtually no cartridge angle misalignment, and since the frictional force of the grooves is always acting directly opposite the anchor point of the tone arm, there is no need for an anti-skating system either. The only real challenge then is getting the tone arm to track the grooves freely. So here we have a realistic LAB-2100 model linear tracking turntable I found on eBay, but before I could play with it, it had some problems needing to be fixed. I replaced the faceplate, which had a crack in the corner that seemed to be making the power button difficult to toggle. Unfortunately, replacing the faceplate did not fix some other problems. For example, the tone arm was stuck and wouldn't move at all. Also, the platter just spun like an Energizer bunny and wouldn't stop. The machine would not respond to any of the controls. So let's take a look at the inside and see if we can find out what's wrong. After taking off the mat and platter, it didn't take long to figure out how to remove this little plate here. Just those 5 screws and it can be lifted out like this. Once you do that, it seems pretty obvious that the tone arm could fit through the slot and that the base cover could be removed, if I could only figure out how to move the tone arm over to the left. So after removing a bunch more screws from the top and bottom, I managed to get the base cover loose, and by peering inside, I could see the servo motor. It drives a small belt, which moves the gears driving the Tonearm Carriage. By squeezing my hand under the casing, I managed to turn that mechanism by hand and move the tone arm over. This short time-lapse clip here shows how much I was able to move the tone arm over the course of about 2 minutes. It was a pretty tedious process, but eventually I managed to move it to a point where I could get the base cover off. So now with the base cover off, let's just see if we can identify what's going wrong here. After powering it up again, I noticed that the tone arm motor was trying to move the tone arm, but the belt was slipping and not transferring the motion to the pulley driving the gears that moved the tone arm carriage. After helping it along, I got the tone arm back to its resting position, and suddenly, lo and behold, the platter stopped spinning and the front panel controls were now responsive. I quickly concluded that the problem was very simple. The electronic brain was trying to reset the tone arm to its rest position on startup, but it was stuck. So it might just be a simple matter of getting it unstuck. Looking at the belt up close, I noticed it was cracked and perished, which is not unexpected for something that old. So I ordered a new belt for the tone arm mechanism from lpgear.com, as well as a new stylus. The cantilever on the old stylus was completely bent out of shape, and I figured it's a good idea to replace it in any case, since I had no idea how much wear the old one had seen. The cartridge itself is the one originally supplied with the machine. Turns out, it's basically a realistic branded version of the Audio-Technica AT-102, which can work with a wide variety of different styli. With the new belt installed, the tone arm moved, but kept getting stuck. It was clear that I should also clean up the old lubrication on the gears and rails, which seemed to have solidified and turned into a sticky, almost glue-like substance. After cleaning up those parts with rubbing alcohol, I relubed the rails with this Tri-Flow lubricant. On the gears I first tried Tri-Flow, but that just didn't seem to cut it. So I tried some white lithium-based grease, which was much better, but still not quite perfect. After playing records for a while, I found that the gears were sticking again, with the result that the tone arm would gradually drift away from parallel, and the motor would start whirring as it struggled to move the tone arm back into alignment, but seemed unable to do so. So I finally cleaned the gears again, and put on some of this super lube I got at the local hardware store, which seems to work pretty well. So this is how the mechanism works. The stylus follows the grooves and gets pulled along to the left like this, and basically every time the tone arm is pulled about 1/10 of a degree away from parallel, this closes a switch inside the carriage, which tells the brain in this unit to activate the servo motor and move the tone arm over to the left to make it parallel again. So here's what that looks like in time lapse. Now that the mechanism was running smoothly, it was time to try playing a record. I tried it first with the platter on and the bass cover off just to make sure it worked, and it did, so I decided to put the whole thing back together and try hooking it up to my stereo system. First thing I noticed was that when I hit play, the tone arm set the stylus dangerously close to the outer edge of the record. After playing a few records, I noticed that it actually did drop the stylus off the edge of the record sometimes. I'm certainly not one that likes to damage styli on a regular basis this way, so I looked to see if there was any way I could adjust this. Now, if you look at the Tonearm Carriage as it moves across here, you'll see this plate in front with slots in it that function like little windows. The slots pass between the red LED on one side and some light sensors at 4 different levels on the other side. As the carriage moves, the varying levels of the slot pass by the LED and block the light to different levels of the sensors on the other side. This is what tells the electronic brains of this machine what position the tone arm is in. Here's when it's at rest. Here's the start of a 12-inch record. Here's the start of a 10-inch record, although the machine does not actually support that size. Here's the start of a 7-inch record. And here's the end of a 12-inch record. And here's the end of a 7-inch record. On top of the Tonearm Carriage, you'll notice these 2 plastic screws here. Now, it took me a while to figure this out, but these screws can actually be adjusted without having to open up this panel here when the arm is at rest, simply by pulling out these rubber caps. The one on the right adjusts this plastic cam here, which changes the offset of this entire front piece relative to the tone arm. In other words, if the rail is shifted to the left, it shifts all of the start and end points to the right, and if this rail is shifted to the right, it shifts all of the start and end points to the left. By shifting these start and end points to the left, I managed to make it start at a safer point and not fall off the edge, but this created a new problem. It wouldn't always pick up the arm and reset it when the record was done. Unfortunately, there seems to be no way to set the start and end points separately, so it was either have it start safely and fail to end, or have it end properly and start dangerously. After some experimentation, I finally came up with my own quick and dirty fix. I set the rail so it would end correctly, and then put some dark electrical tape over the 12-inch and 7-inch starting positions on the rail to get the starting position right. I'm not sure why it wouldn't work without this fix. You would think they would have designed it to work properly with what it had, but in any case, it now works like a charm. So now it's time to see what this turntable can do. As you can see, this 50-year-old record is rather badly warped, but this is the only record I could find that is completely copyright-free, and in a way, it also shows just how amazingly well this turntable can track a badly warped record. You'll notice that it never skips. So without further ado, here's a sample of its sound recorded directly from the turntable by way of the phono preamp in my Sherwood stereo receiver. So there it is. The final step in the process was simply a bit of cosmetic detailing. The dust cover was pretty cloudy and scratched up, so I polished it with some Novus Plastic Polish No. 2, which, as you can see, did a nice job of getting rid of all that. It looks almost as good as new.
Hopefully this video will inspire those of you who own this turntable or want to own one to take them out and fix them. The realistic LAB-2100 was in the Radio Shack catalog in 1984 and 1985. While we're at it, it might be worth mentioning that this turntable was made by a Japanese OEM maker who made models nearly identical to this one for many other brands as well, with only minor differences in cosmetics and features, including the Mitsubishi Medallion Series LT-4, the Onkyo PL-25F, the Sherwood ST-903, or the Sherwood ST-905. Most of them appear to have been made for the North American market and only support 60 Hz operation, but some models like the Sherwood ST-903 and ST-905 do support 50 Hz operation as well for those of you in places like Australia, Europe, or the UK. If you're intrigued by the idea of a linear tracking turntable and you're willing to do a little tinkering, there are lots of good options out there. Thanks for watching.